Hi, my name is Petri Kainulainen and this is the first part of my tutorial which talks about the unit testing of Spring MVC controllers. This video describes how we can configure our unit tests which uses the Spring MVC Test framework. Let's get started. This tutorial is divided into 4 parts. The first part describes how we can get the required dependencies with Maven. In the second part, we'll take a quick look at the controller which we are going to test. The third part describes how we can configure the application context of our application and create an application context configuration for our tests. In the fourth part, we will learn how we can configure our test class. The first thing that we have to do is to get the required testing dependencies. Let's see how we can do this. We can get the required dependencies by declaring the following testing dependencies in our POM file. JUnit 4.11, Mockito Core 1.9.5 and Spring Test 3.2.3. Release. The example application of this tutorial provides CRUD functions for to-do entries. In order to understand the configuration of our test class, we must have some knowledge about the tested controller class. At this point, we need to know the answers to these questions. 1. What dependencies does our controller class have? And 2. How is our controller class instantiated? We can get the answers to these questions by looking at the source code of the to-do controller class. Here is the source code of the to-do controller class. As we can see, our controller class has 2 dependencies, to-do service and message source. We can also see that our class uses constructor injection and it has a single constructor which takes 2 parameters. Message source and to-do service. This information will help us when we are creating the application context configuration for our tests and when we are configuring our tests. Maintaining a separate application context configuration for our application and our test classes is cumbersome. Also, it can lead into problems if we change something in the application context configuration of our application, but forget to do the same change for our test context. Let's find out how we can solve this problem. Because we don't want to create separate application context configuration files for our application and for our test, we have to follow these steps. First, we have to divide the application context configuration into smaller parts. The application context configuration of our application is divided into 3 parts. The first application context configuration class is the main configuration class of our application. It imports the other configuration classes and configures component scan for service classes. The second application context configuration class is responsible of configuring the web layer of our application. The third configuration class contains the persistence configuration. Second, we have to reuse parts of the application context configuration in our tests. In our case, we will reuse the application context configuration class, which configures the web layer of our application. Third, we have to create a minimal application context configuration for our tests. The next thing we'll do is to take a look at the application context configuration of the web layer. The application context configuration file of the web layer has the following responsibilities. 1. It enables the annotation-driven Spring MVC. 2. It configures the location of static resources. 3. It ensures that static resources are served by the container's default servlet. 4. It ensures that controller classes are found during the component scan. 5. It configures the exception resolver bean. 6. It configures the view resolver bean. Let's check out how we can configure our web layer by using both a Java configuration class and an XML configuration file. The source code of the web app context class looks like this. If we use Java configuration, we can configure our web layer by following these steps. First, we enable the annotation-driven Spring MVC. Second, we ensure that the controller classes are found during component scan. Third, we set the location of static resources. Fourth, we ensure that the static resources are served by the container's default servlet. Fifth, we configure the exception resolver bean. Sixth, we configure the view resolver bean. The source code of the example application context web.xml looks like this. If we use XML configuration, we can configure our web layer by following these steps. First, we enable the annotation-driven Spring MVC. Second, we set the location of static resources. Third, we ensure that the static resources are served by the container's default servlet. Fourth, we ensure that the controller classes are found during component scan. Fifth, we configure the exception resolver bean. Sixth, we configure the view resolver bean. Let's move on and find out how we can configure our test context. We can create the application context configuration for our tests by following these steps. First, we have to configure the message source bean. This bean is used by the to-do controller class and Spring MVC. The reason why we have to do this here is that this bean is configured in the main configuration class of our application context configuration. Second, we have to create a to-do service mock, which is injected to the to-do controller class. Let's find out how we can configure our test context by using a Java configuration class and an XML configuration file. The source code of the test context class looks like this. As we can see, it's a pretty simple configuration class which configures the message source bean and creates the to-do service mock. The source code of the test context.xml configuration file looks like this. It's a pretty simple configuration file which configures the message source bean and creates the to-do service mock. And finally, we are ready to start configuring our test class. Let's see how this is done. We have two options. The first option is so-called standalone configuration. It allows us to register one or more controllers and configure the Spring MVC infrastructure programmatically. This is a good approach if our Spring MVC configuration is simple. The second option is to use web application context-based configuration, which configures the Spring MVC infrastructure by using a fully initialized web application context. This approach is the best choice if our Spring MVC configuration is so complicated that using standalone configuration doesn't make any sense. Next, we will configure our test class by using these options. If we use the standalone configuration, we can configure our test class by following these steps. 1. Annotate the class with the runWith annotation and ensure that test is executed by using the Mockito JUnit runner. 2. Add a mock MVC field to the test class. 3. Add a to-do service field to the test class and annotate the field with the mock annotation. This annotation marks the field as a mock. The field is initialized by the Mockito JUnit runner. Add a private exception resolver method to the class. This method creates a new simple mapping exception resolver object, configures it and returns the create object. Add a private message source method to the class. This method creates a new resource bundle message source object, configures it and returns the created object. Add a private validator method to the class. This method creates a new local validator factory bean object and returns the created object. Add a private viewResolver method to the class. This method creates a new internal resource viewResolver object, configures it and returns the created object. Add a setup method to the test class and annotate the method with the before annotation. This ensures that the method is invoked before each test. This method creates a new mock MVC object by calling the standalone setup method of the mock MVC builders class and configures the Spring MVC infrastructure programmatically. Using the standalone configuration has two problems. The first problem is that our test class looks like a mess even though our Spring MVC configuration is rather simple. Naturally, we could clean it up by moving the creation of Spring MVC infrastructure components into a separate class. This is left as an exercise for the viewer. The second problem is that we have to duplicate the configuration of Spring MVC infrastructure components. This means that if we change something in the application context configuration of our application, we must remember to do the same change to our tests as well. If we use the web application context-based configuration, we can configure our test class by following these steps. 1. Annotate the test class with the runWith annotation and ensure that the test is executed by using the Spring JUnit 4 class runner. 2. Annotate the class with the context configuration annotation and ensure that the correct configuration classes or XML configuration files are used. If we want to use Java configuration, we have to set the configuration classes as the value of the classes attribute. On the other hand, if we prefer XML configuration, we have to set the configuration files as the value of the locations attribute. 3. Annotate the class with the web app configuration annotation. This annotation ensures that the application context which is loaded for our test is a web application context. 4. Add a mock MVC field to the test class. 5. Add a to-do service field to the test class and annotate the field with the auto-wired annotation. Add a web application context field to the test class and annotate the field with the auto-wired annotation. 7. Add a setup method to the test class and annotate the method with the before annotation. This ensures that the method is called before each test. This method has two responsibilities. It resets the service mock before each test and creates a new mock MVC object by calling the web app context setup method of the mock MVC builders class. The configuration of our test class looks a lot cleaner than the configuration which uses standalone configuration. However, the downside is that our test uses the full Spring MVC infrastructure. This might be an overkill if our test class really uses only a few components. Let's spend a moment to summarize what we have learned from this video. First, we learned that it's wise to divide our application context configuration into smaller parts and reuse those parts in our tests. Second, we learned that the standalone configuration is a good choice if our Spring MVC configuration is simple. Third, we learned that the web application context-based configuration is a good choice if our Spring MVC configuration is so complex that using the standalone configuration would result in a mess. That's all for today. You can get the example application of this tutorial from my website www.petrikainlainen.net. I have also added link to the description of this video. If you enjoyed watching this video, you might want to follow me at Twitter. My Twitter handle is @petrikainlaine. Thanks for watching. Hey hey!